Okay, in this episode of Throttle Stop Garage, we're going to take some plastic tube and some stainless steel tube, and we're going to build a merge collector for our turbo manifold. Stay tuned. Of course, the easiest way to build a merge collector is just to find somebody online who's selling one and then just purchase theirs. But if you're like me and you'd like to know how to build these things and get it done in your own garage, then you're going to stumble onto a few little problems. One of which, everyone seems to treat this basic geometrical problem as some kind of secret, trade secret or something, and you find all kinds of sort of crazy ideas as to how we would go about getting this done. So I thought I would do something that I hope will be helpful. So I've got here, I've taken from my ABS and I've cut just some rounds. I made them nominally 40 millimeters long. It doesn't matter what the length is, just chop a few up. Okay, so we know right off the start that we have 360 degrees. And we know we're going to have 5 tubes that are going into that 360 degrees. Okay, so that means each tube is going to be separated by 72 degrees in this case. So whatever we do, for everything that we do, 72, that's the number that solves all your problems. If you're going to have your merge collector come out round, all the angles need to sum for each part to 72 degrees. So the tricky part is, now how do we work out where the flange, and again it could be a T4, T3 style flange, I happen to be, the turbo that I have has a V-band, doesn't matter, but you have to work out what the angles are, and that seems to be what stumps everyone, is where do the angles come from? So let's just talk about that for a minute. And I know if I assemble them and I hold them as tight and as evenly as I can, that the angle between any two tubes is going to be that 72 degrees that we had before. Now, if we then take the turbo flange, for my turbo I need a V-band, and it's 2 1/4 or 57 millimeters is the inlet. So we know we need to move it up at some height in order to get the tubes to merge into that collector diameter. We could measure what the diameter of this circle is, which happens to be 70 millimeters, or the radius is 70 millimeters, the diameter is 140. But I know that the end result of taking these tubes and drawing them together is going to be that they will splay out. Now, when they splay out, that's our splay angle. We need to know the angle here. This is where most people get tripped up, is trying to work out that angle that these tubes need to enter into the turbo at. So the first thing I did to work this out, because how do you work this out? Read forums online where people are being a little snotty and insinuating that surely if you're able to walk upright, you can work out this geometry. It's not true. Okay, so what I've done here, empirically, it's the easiest way to do it. So I've taken the tubes, I've set them apart. I mean, I understand they're going to tilt in, but I've set them apart at an angle that I think I can weld them at. Right? I'm pretty sure I can get my torch in, say a 10 millimeter distance is going to be a pretty reasonable thing that I can do. And if I move them in that 10 millimeters, that's going to increase this diameter, right? So the radius increases to about 75. I can then place the flange above the tubes, and then I can work out the angle. All right, so then as soon as we know what this diameter is, we can just go ahead and draw it. I'm just going to make a simple scaled drawing. The base is going to be 75. Okay, so that's to the outside of the tube. Okay, so now we know that the diameter here is 57 millimeters, which leaves us about 28.5 millimeters in radius. So wherever we put the ruler, So if we went to 28.5, right, we could then, that now describes the angle between that point and this point. Okay, so you just go up and down and try to work out your angle and go, okay, where can I get it? Now, you'll notice as you're doing that, that your collector length, right, the closer you put it, the shorter it gets, but the angle increases quite a lot. Right, so you've got some constraints to sort of work around. And that, by eye, looks pretty good to me. I'm just going to draw a line in. Connect the two lines. And then you go ahead and measure your angle. And I've got an angle in this case, so this is going to be this is going to be my collector size. So this collector height here, again, it's a reasonable height. It's not outrageous. It's going to package okay. But where I've placed it here, this gives me an angle of 20 degrees. We physically modeled that just with our tubes. Hold them in tight, separate them out just a little bit so you know you can weld between the tubes, and then work out your angle based on that circle, this circle diameter or radius here, and this circle radius here. So if you want to get fussy. Now, what do we do with the 20-degree angle? That's very nice. So we know we've got 72 degrees total, and we know that whatever we do, each one of the cuts that we make on our tube have to total 72 degrees, or our merge collector won't come together. It will not close. You can't close the circle using magic. You take the 20 degrees that you have just modeled here, and you divide that by 2, because you have 10 degrees on each angle. Okay, so 10 degrees on each angle. So then 10 degrees becomes your cut angle. So in my case, I've made a simple jig. This angle on the jig is 10 degrees to this angle here, to where it sits against the fence on my chop saw. And then I've put a small stop in here that holds the tube. So the tube slots in behind quite tightly, right? And then it's stopped. And then all I need to do is clamp the tube at the end. And I've carefully marked in where the tangent is to the tube of the diameter that I'm using. So I've got a nice line marked in here. That's my tangent. This is important. The next part has to do with figuring out the geometry of that tube. So we know our angle that we're going to cut is going to be 10 degrees. What we need to know is, in reference to the jig, so if this is our one tangent here on the jig, we need to know, so the saw, so we know that we've got this inclined at 10 degrees here. The saw is going to make a straight cut to a tube that's running diagonally. Okay, we need to know where the next angle needs to be cut so that we can mark the tube. Right? So we need to know where that angle is. Okay, so let's just work that out. Each cut is going to be 180 degrees. And we know at the angle that we have, this 72, and then we're going to put the 10 degree included angle, we know that's going to be 62 degrees. So we know that the separation between these two has to be 118 degrees in order for this to work out. So this is what I've done, is I've 3D printed a pie-shaped piece that fits my tube exactly. It's got 118 degrees of separation, and I'm simply going to take a marker, mark those two lines, and then as I cut it, make sure I do it right, I'm going to line the line up here, make my cut, rotate it to the next line, clamp it, make my cut, and that will give me this part. You can see the two lines here and here. There's one last check. Then this angle. Okay, so if we've done this properly, it's now 72 degrees. So you can always check to make sure that your parts are turning out right. So I'm just making the plastic part here. This is early days, as you already saw the plastic one cut, but you gotta try it out first and make sure everything's going to work. And then once I was happy with how the jig functioned and explained to you how it all works, I cut 5 more parts and made sure that I could actually get that merge started. Right, so we've got it. It's closed up. It won't be any problem to weld this. You can see the angles aren't all, the angles are cut properly. It's just, we need to kind of get in there, pinch them up a little bit. And hey, that's about exactly what you want getting started trying to make merge collectors. It's a bit brutal to watch that diamond blade rip through the stainless steel. It's not easy to cut, especially on the bottom half where the blade basically gets bogged down, so you just take it easy. Then over to the big belt sander to touch them all up, and they are ready to roll. All right, now, you don't actually need a weld positioner, but Certiflat had them. I bought them when they'd still sell to me, which is kind of comical. And then I thought I would just do a little bit of actual stop motion. So as much as you don't need the positioner, you do need a chill block. You need to pull all the heat out of that flange that is possible. So I just built my own. I had some bits of aluminum lying around, and well, I lost all the footage of getting it together. It's not really all that exciting. So here you go. It's all finished. I couldn't find any really good information on how to actually do this. A lot of people just assemble all the pieces together and then try to weld it all up. I decided I would tack it on the inside first and then put it together as a set of 2 and a set of 3, and then I'd only have one weld line between the two. Now, when I'm doing the welds on the inside, and I'm going to talk about it here in a bit, I am using a back purging box there just to ensure that I'm not getting any of that really nasty carbide precipitate stainless steel nonsense there on the inside or the back side of the weld, which will become the outside of the collector. One wouldn't want that. But this was a way that I could ensure that I would get 100% penetration. It's hard to do, especially in some areas of the tubes, like where they join right at the top where they branch in. It's so thick up there, it's just about impossible to get that to work. All right, just in case it didn't show up on the video lapse, this is the little purge box that I'm using. Crummy Welding was... Oh. Crummy Welding was selling them, so it's just a little stainless steel purge box that you put together, and that was allowing me to get the back side of those areas purged. Well, I tacked them up so that the area that I'm actually welding, so if we look in the weld prep area here, you'll see that we have no sugaring or contamination or anything on that, which is then going to be the front side of the weld, and we'll pound as hard as we can to push through to the join that we made when we welded up the inside. I've just installed some silicone plugs, so they're cheap, and I have to get in and weld the middle piece. All right, so just a piece of foil tape, a couple of holes poked in it, and then my purge line coming in on the bottom side. And now that we're happy with how the tacking is gone, the purge line is set up. Again, you let it sit for a minute or two in order to clear the tube, and then just to evacuate all the air out of the tube. And you've got the gas flowing pretty much the entire time, so you're working on it. I also have some pliers there on the bench that if I'm going to walk away from it for any length of time, I do clamp it off just to save on argon a little bit. And the tape pretty much melted out on me as I was doing it. I'm trying to keep it cool, so the air line is always coming out and blowing it. So I had to give up on the tape and go grab some tin foil and ball it up. And that usually works just fine in order to get this kind of stuff done. So I'm working at it in small pieces at a time. And each time that I'm doing that, again, you can hardly see it, but I am blowing it to make sure it's cool. And occasionally I will actually take my welding gloves off and check it by hand just to make sure that it's cool. And there you see, that's the pliers coming in useful there as I burn through the bottom plug and have to resort once again to the tin foil. All right, once that's done, level it up, mark it off around the edge, and chop the get brave, and then cut the whole bottom of the tube off. Obviously, my intersection there is getting into the tube a little bit more than is required, so I just chop that off. And then over to the dolly I went with the hammer, and then I discovered, yeah, I'm not working with tube. This is Schedule 10 pipe. So it may be 321 stainless, but you sure can't move it with a little hammer. So you got to get the propane blowtorch out, warm it up to about 400 or 500 degrees Celsius, and then I hit it with an air hammer with a specially modified end on it that can dolly this stuff out. So I wanted to very carefully fit it so that it fit perfectly to my V-band collector. So I'm trying the V-band collector on it all the time, and as soon as I've got it out and round, that's when it's done. Then it's over to the bench, and I've got to weld the inside. So I bought a pencil torch for my TIG, but I bought a 26, right? So it's the big one. It makes it hard. I couldn't see in there at all. I had to feel around with the end of the tungsten so I knew I was on the intersection, and then hold it off a little bit, push and pray. So that was not easy. Then clean up the inside. So any of the, just to smooth it out, any of the weld areas that have, again, you're melting that material back. So you'd like to get that the cleaned up so the flow is nice. Get in there with the angry end and get it all blasted out. Doesn't take very long. It's kind of delicate work. Then a flap wheel to touch it up, and you're done. Well, I was struggling over at the bench to try to give you a look inside at the finished collector. I am happy with how that all turned out. I think you can see that pretty well. There's a few little flaws inside, but nothing that I'm going to worry too much about. Just little areas where it's a little inconsistent given that I was melting the material down. It's not going to be perfect every time when you try to pull something like that off. Again, never made one before, so pretty happy with that as my first try. So looking all right to me. But we now have to get the special, okay, so it's with the turbo that I have, I need a stepped flange on the V-band collector, and I need to get the V-band collector onto the merge. And again, hoping you can see, the fit's really good. Now, it's hard to get the fit to be that really good. I don't want to be filling, you know, with the welding wire, I do not want to be trying to fill huge gaps. That's not what this is for. So we're not, you got to get out of a MIG mentality when you're TIG welding things. That's not the idea. So the manufacturers have given us a little step. And what I'm going to do is I'm going to set this up on my press, because you can see here, I can get it on, and I can get it in the hole like most of the way, but it's kind of hard to hold it because I'm coming up against an angle. Okay, and that angle is wanting to always tilt the connection one way or the other. Now, before I go and put it up onto my rig where I'm going to back purge it and weld it fully, I'd like to get it tacked up. And I can only get this on about 1.5 millimeters, and it's got a 3 millimeter step. But if I set it in the press and just carefully put a little pressure on it, I can get it to sit down just fine. All right, so it just lets you know how much work you actually have to do to make one of these things any good. And I don't know if this is, I mean, would you do it this way? I don't know. I don't care. I'm doing it this way. I like to have my fits really nice first and then weld. And it does make makes a lot of stuff easier if you just do the extra work. Okay, so let's get back to the press here. I've moved it out from its new location on the new clean bench. So it now sits out a little bit where I can get access to it, which is nice. And with my little level, I can verify that we're level. We are in both planes, so that's good. Then when I put the flange on, again, that means that the bottom half here is level, then this is level, and then I'm just going to slide in. See, that's how tight this is. Just going to put a little 10 millimeter plate in here. Level it all up again. I mean, technically this will pull level as you're applying just a little bit of force, just enough force to hold it. We're not trying to win any races here. We're just trying to clamp it up. So we're kind of clamped top and bottom now. Level and level. My levels don't make any noise. We'll be okay for a tack. Just hate these things. Seriously, is everything going to go wrong today? That part. Okay, so everything that can fail did fail, as always. I don't know, you probably can't see in here very well. Whoa! Where's the focus? There we go. Okay, so you can see we've got it up tight against that shoulder all the way around, which means that we're nice and tight here all the way around. So there's not a ton of, well, there's no gap to fill on that seam, and that's what we want when we go and put it on the weld fixture and try to get this thing sunk in. Last process for the whole thing, and it did take me a little while to make the weld fixture, but it was no big deal. So the first time I ever used it, it was the first time I've ever used the weld positioner as well, and I discovered that if I tried to do anything with that, with the drill that you're meant to run it with, it just didn't work at all. So sorry, Certiflat, but your gear ratios are wrong, and I can't turn the thing slowly enough to make it reasonable for TIG welding this part. So I just used the weld positioner to, you know, advance it kind of a fifth of a turn at a time or whatever I did. And it seemed to work pretty good that way. So that was fine. Well, who cares? It worked. And that's the V-band all welded on. Everything's just fine. And yeah, of course, the back purge you can see I've barely got any discoloration even on the inside. Oh, it's hard to show. On the insides of those tubes. In fact, I was going to show you if it will show up. There, you can see right there. That's a Sharpie mark I made when I was trying to get this part fit into my chill block. The Sharpie will burn off at about 500 degrees Celsius. So we didn't really get it all that hot. Now, just for show, what you're after is that. Okay, so that's fitting perfectly. No rock. So I just wanted to show you the difference between a weld that's been back purged and one that hasn't. That's the material, the precipitate that happens on the backside of stainless steel when you don't back purge. It may be going down flow, but if it's going into your turbo, I wouldn't want any of that stuff breaking off. Probably no big deal, but it's ugly, and why build ugly in your garage? That's not okay. Alright, so that's a wrap for this episode. Everything turned out. I am happy with the collector. Now the hard part comes when I try to get everything put into the car and build the rest of this manifold out. I know I didn't show it on camera, but don't forget to practice. I don't weld very often anymore, so I did take some tube, all little bits and pieces. I welded some coupons. I did simulate the welds that I was about to make so that I was sure that the weld process that I was engaged in worked really well. I also wanted to give a quick shout out to Justin at the Fabrication series. So of all the YouTubers that I've contacted online, very few ever get back to you. I had a few questions. I shot him out a message, and right away the guy got back to me. So happy to get a little bit of advice from the pros on how to make these particular very complicated parts, actually make them and have them turn out really well. Okay, so with that, that's a wrap for this episode. Thanks for tuning in. Like, subscribe, do whatever you like. Anyway, keep your stick on the ice.